Welcome to lesson 2.8, rewrite equations and formulas. So the first vocab term that's going to show up is a literal equation. And a literal equation is when you replace every number with a variable. So for example, we know that the standard form of a line is ax plus by equals c. This is a literal equation because there's no numbers in it, it's all variables. The reason that literal equations are helpful is if you can solve it, like if you can rearrange your equation to solve for whatever value you want, you can then replace in whatever numbers you have. If your numbers keep changing, you can then solve it a lot faster. So let's go ahead and solve this literal equation for x, and then we'll solve the other equation. So ax plus b equals c. We need to solve that for x. So what that means is we're trying to get x by itself. So first thing, let's just subtract b from both sides. So we'll be left with an ax equals c minus b. Now to get x by itself, we just have to divide both sides by a, and we'll be left with x equals c minus b over a. We now need to solve this for 2x plus 5 equals 11. Well, the 2 is in the same spot where the a was, so that's going to be on the bottom. The 5 is in the same spot as the b, so that's going to be what's subtracted, and the 11 is in the same spot as the c. So 11 minus 5 is 6, divided by 2 is 3. Now let's say they all of a sudden changed that number on you, which I guarantee you, if you get a job, they're going to keep changing numbers on you all the time with little warning. So you have to be ready to adapt fast. So let's say, oh, didn't mean to do 2x plus 5 equals 11. The boss is now saying it needs to be 3x plus 2 equals 17. Well, now you can still do the same thing. You can go and plug in your 17 for C. You can go and plug in your 2 for B. And you can go and plug in your 3 for A. And now you'll know 17 minus 2 is 5 divided by 3, or sorry, 17 minus 2 is 15 divided by 3 is 5. So even though they just changed the numbers on you, you can solve it quickly without actually having to do a lot of work in order to do that. So now let's do this next one. Write this equation, so y is a function of x. When you see y is a function of x, that means we want to solve for y and have x and everything else be over on the other side. So y on our left side, x and everything else on our right. So we'll rearrange it to do that. So first we can subtract our 3x from both sides. And we'll have a 2y equals an 8 minus 3x. And now we can divide both sides by 2. So we'll be left then with y equals 8 minus 3x over 2. And y is now written as a function of x. Now let's try it with some other formulas. We know the area of a triangle is 1/2 base times height. What if we want to solve for the height? If we know the area and we know the base, but we need to solve for the height? Well, first thing I'll do, I will multiply both sides by 2 to get rid of that 1/2. So we'll now have 2a equals base times height. We can now divide both sides by the base to get the height by itself, and we'll have a 2a over b equals h. Now we have information, so we can find out, oh, if our b is 14 and a is 64.4, well, we can now plug in 2 times 64.4, divide that by 14, and that's actually going to come out to be about 9.2. So that will be our answer for this one. Ooh, here's another fun one. This is an equation that converts from degrees Fahrenheit to degrees Celsius. So our degrees in Celsius is equal to 5/9 times, in parentheses, your degrees in Fahrenheit minus 32. If we want to solve this for the Fahrenheit, say we have our degrees in Celsius and need to get back to Fahrenheit, well, first thing I'd do is I'd multiply both sides by 9/5 times 9/5 to be able to get that to cancel out with our fraction here. So we'll now have a 9/5 c equals f minus 32. We can now add 32 to both sides. And that will get us F by itself equals 9/5 C plus 32. Clearly, when whoever invented the Fahrenheit and Celsius temperature ranking system, they were not communicating with each other, because this is kind of gross for converting back and forth. But now we can convert 14 degrees Celsius and 10 degrees Celsius to Fahrenheit. So let's go and plug in that 14 in for C. So 9/5 times 14 plus 32, 32, that's going to come out to 57.2 degrees Fahrenheit. What about we try the 10 degrees Celsius? 9/5 times 10 plus 32, that's going to come out to be 50 degrees Fahrenheit. So it was a 4-degree temperature difference in Celsius, but it was a 7.2 degree temperature difference in Fahrenheit. So that's just something that is kind of weird and unique between them. So that's it for this lesson. As always, if you have any questions, make sure you let me know. And other than that, good luck.